What is a cobot? So you may already know what a cobot is. They're pretty popular in the market, but if you don't know, we're gonna explain that today. So a cobot is a collaborative robot. And a collaborative robot essentially means, at the most generic terms, you can work around it, right? It means that you can have a human standing right next to the robot and the robot can perform its task. Now, the number one advantage to a collaborative robot is that you can work around it, right? The second most largest advantage, and may even actually be the number one advantage, it's the ease of deployment, right? It's the ability to utilize the robot in an operation with the least amount of effort. So almost anybody can walk up to a collaborative robot, be able to drag it down, teach a point, drag it back up to another point, drag it to a place point, and teach the robot. And the programming is really that simple. There is a little bit you have to do on the programming side of things. However, again, it's a very, very easy process. Now, one thing that I do have to advise that individuals do is they equip this robot with the proper tools. And when I say individuals, I mean the company owners, the management, the directors, the ones who are trying to drive the decision to utilize collaborative robots. They need to ensure that these robots are equipped with the right tools. And what are some of the right tools that I feel like you need with a collaborative system? Some of those tools may be vision systems for vision location. If you're doing a welding operation, it might be seam tracking, or some other seam identifier or seam tracking technology. Maybe it's a touch type of seam tracking versus a vision optical type of seam tracking. But these robots have to be equipped with some tools that are gonna make it a little bit more easy to deploy this robot from place to place. Now, maybe you're putting it in one place and you're not moving it around very often. And in those instances, maybe it doesn't matter that it's super easy to redeploy. However, a lot of companies that are going with collaborative robots have the idea that they're gonna be able to move this robot from station to station, or as they are in production with certain part numbers, they think that they can use this collaborative robot in different locations as maybe that part switches between locations. Let's use injection molding as an example. In injection molding, sometimes your mold will go in press number 10, sometimes they'll go in press number 6. Like, they kind of switch around in how these different parts are being ran inside of different machines. With that being said, the companies are also wanting to switch the robot around with those molds, so that way the robot can pick up that part. And why are companies wanting to pick up that part? Well, the reason why the companies want to pick up that part is because they've identified that part as an easy part to handle, and a part that a robot can easily handle. And maybe in an injection molding process, it might be there's no quality issues with that part ever. They've never had quality rejects. So since there's no quality issues with that part, maybe they don't need a human inspection. So since they don't need a human inspection, they can then put a robot in place of the packing of that product. And also that's one of the big things that prevents a lot of systems from being able to be automated. There's a ton of like end-of-line systems that would be a very, very ideal process to automate. However, there's a human inspection portion of that operation that is very hard to automate. Maybe the vision inspection systems are just not doing a very good job at being able to detect whatever the defect condition is. So if there's any other questions you have with like what type of tools that you should put on a collaborative robot to ensure that it's adaptable and able to be moved around through different operations, feel free to reach out to us, or you can just put a comment down below and I can answer via text, or we can jump on a meeting. Now let's jump into some of the one other advantage that goes into the quick deployment of these systems is you don't need fencing, right? That's one of the big things that people call out is you don't have to fence this robot. And you actually don't have to add any other safety devices as far as light curtains or laser scanners. However, if you don't add light curtains or laser scanners, you have to run this robot at an extremely slow speed. It's gonna move like a snail, and it's gonna basically just move just like this. Right? So in order to move any quicker than that, you will have to equip it with a laser scanner, which will increase the cost. And sometimes the cost of like a laser scanner is just as much as fencing. So when it comes to like feasibility of these things, so a lot of people don't understand when comparing a traditional robot versus a collaborative robot, is that a lot of times like certain things like a laser scanner will increase the cost so much that you can just go ahead and fence in a whole entire robot. Right, so you're not actually saving money. So I wouldn't necessarily look at the collaborative robot as being a way to save money. Now it could be, right? I'll give an example of where maybe this is a cost-saving initiative. Maybe you have 5 collaborative robots that you want to put them all right next to each other, and you're able to use like one laser scanner to protect all 5 of those robots, right? And that's completely doable, completely legal, and it's gonna save you a ton of money. Now, you could put a fence around those robots, or you can keep them open and collaborative and put a laser scanner on them and have that one laser scanner be able to protect all of them, which is again gonna reduce the cost of the system. So something like this is where you can get a really big bang for your buck with the ability to, you know, deploy multiple of these robots, use one safety system to protect all the robots and give you some advantage in the feasibility. But again, feasibility is not one of the #1 reasons to go with a collaborative robot. Now going into some of the disadvantages of a collaborative robot. And it's that even though the robot is very simple to, there's still a lot of people that are gonna struggle with being able to deploy the robot. People who are just not tech savvy at all, people who just don't wanna deal with robots, people who are not robot friendly. They just say, oh, that, you know, whatever, right? There's a negative culture around robotics itself or around automation itself. Like if you have individuals expressing things like, that thing's gonna take my job or any type of negative remarks like that, then it's highly likely there's not a culture in the company that's gonna help promote that system. And that's where I see a lot of the failures of these type of systems with this entire life cycle. One of the reasons why things like collaborative robots don't last for a very long time and why they end up in a corner collecting dust is because of the culture around the robotics. And just the team is not super excited to use it, or they get pulled off to do something else. They go to training for 1 week, and then they don't get to mess with the robot again for 3 weeks. Now they forgot everything that they learned at training. And so I see a lot of these type of scenarios that are preventing people from being able to utilize these robots, to want to be able to utilize these robots long term. And another thing that I'm seeing is that the upper management that was excited about, let's do this thing, let's use collaborative robots, they lose interest in the collaborative robot. They lose interest in trying to go for that initiative, or they start getting feedback from the shop floor and individuals saying like, oh, this is not as easy to integrate as we thought it was gonna be, or oh, I don't know how to do it, right? They get technically hung up, and then there ends up being some pushback, and then they're expressing this to the upper management or whoever it is that's in charge of wanting to do these collaborative robots and do a collaborative robot initiative where they deploy a bunch of them into their facility. And then the upper management is no longer pushing for the collaborative robot to be used. So I highly suggest if anybody's going to do collaborative robots or utilize collaborative robots in their workspace, that they create a procedure and a culture around it, right? That this thing becomes something that you guys drive towards, that again, it becomes an initiative. It becomes a procedure that you guys follow and something that you can embed into your culture. Another big thing about collaborative robots and why like upper management will abandon it is the cost is not that high, right? You're talking about $30,000, $40,000 or something like that for a deployment, and especially if you do the deployment internally. But it's easy for a lot of big companies to just scratch off $30,000, $40,000 as a loss. Oh, okay, it didn't work out, fine, whatever, right? And then it just gets pushed back in a corner. I've seen some massive facilities where some of the individuals in the company don't even barely know that they have a collaborative robot in the corner. It got written off as some like R&D type of budget, or hey, let's try it out type of budget. And then from there, it just did not go any further. And that's why I see that there's not a lot of success in the collaborative space, or when I don't see success, that's one of the major reasons why I don't see the success. Another disadvantage that I mentioned before is just the feasibility. A lot of times it's not any cheaper going with a collaborative robot versus a traditional robot. And then going to one of the major differences between a traditional robot and a collaborative robot is that a collaborative robot is much slower and delicate than a traditional robot. So when I say it's much slower, just in a head-to-head battle, a traditional robot can move much faster than a collaborative robot. Now, when I say that it's more delicate, I'm not saying that it's not necessarily a robust system. What I'm saying is a lot of times there can be issues with its motion, right? Because it has torque sensing, which is what gives it the ability to detect that it's hit something. Sometimes super fast motions will also trigger this torque sensing, and the robot will think it hit something, even though it's just its own inertia that triggered this crash condition. So a lot of times they can be more delicate, whereas like, just say for instance, if you're placing something down and you place it down kind of hard, a traditional robot a lot of times maybe can hit and go, right? Versus a collaborative robot will be more sensitive and to be able to detect that hit a lot more easily. and then it'll fault out, and then the robot will be stuck in that position. Somebody will have to come and maintain the robot and get it back into a good running condition, which is not that big of a deal unless you're trying to run the robot at like 100% speed, and this condition occurs all the time. So then a lot of times you have to crank down the speed to ensure that it doesn't fault out. And so now you're not running at 100% speed, you're running at 80% speed. And the other thing, when it comes to speed, the risk analysis still has to be done on the collaborative robot and what type of dangers that it emits to the individuals around it, right? And so whenever it comes to speed, anytime there's any type of pinching point or crushing point, that speed has to be highly reduced, right? And so like whenever I was saying the robot would hit this crash condition, generally that wouldn't happen, at least if your robot's programmed safely, because this place position should be a pretty soft place. Because one thing you have to do in your risk analysis is, let's say for instance, if your robot's moving very quickly, you have to do a calculation of if you stick your hand in there when the robot was doing the place operation, what is the likelihood of injury and how bad or how severe is that injury? And whenever you have a metal object moving through space, and you put your hand between it and another metal object, it's highly likely that the injury could be pretty severe. I mean, it could be as severe as breaking your hand, right? And you hear a lot of other people mention funny things about like, you can't put scissors on the end of a collaborative robot and call it collaborative, right? So any type of like sharp metals that are on the robot, you have to keep those things in mind, because if the robot's swinging around with some metal tool and it hits somebody directly in the head, you know, it technically could be a fatal injury. So you just have to keep those things in mind, and that if with working with the collaborative robots, that you're making sure that you're implementing things that make them then safe again. Especially like if you have a metal tooling, put some type of guarding around it, some rubberized guarding. And you just gotta be very careful with those type of things as well, because then you gotta make sure it's affixed well, because adhesive to glue it on, and then 3 weeks later it falls off. And then that's how you end up with an injury that happens some months later, because you know you put the safety guard in place and then maintenance took it off to do maintenance tasks, and they didn't put the guarding back on, and then now you have an exposed safety issue. And it can be easy to happen with something like a collaborative robot, where a lot of people don't have that understanding, or sometimes that thought process of why is this thing happening, or why is this thing in an unsafe condition. Hopefully this gave you a little bit of an understanding of collaborative robots. If you have any more collaborative robot questions or anything automation related, put it in the comments below. Also, anything career advice related, make sure to check out our Manufacturing Come Up playlist / podcast that's on all major podcast platforms, where we help navigate people through their careers and how to be successful. Catch you on the next one.